Welcome. Today we're going to talk a little bit about what we mean for the domain and range of a function. Again, we haven't really talked a lot about exactly what a function is, but a function is a special type of a relationship that matches numbers together, puts them in pairs, ordered pairs, a set of ordered pairs where I have 1 paired with 3, 2 paired with 5, 3 paired with 7, 4 paired with 9, 5 paired with 11. This is a function. Now, all sets of ordered pairs are not necessarily functions. They might just be a relationship. And we'll talk more about that later. But right now, let's just talk about what we mean by the domain of a function and the range of a function. The domain are basically all the possible input values that are allowed, all allowable inputs. So looking at this set of ordered pairs down here, if I was going to talk about its domain, I would say its domain is, and I would do it in a set of numbers using these brackets where I take just the input values. So the input are the x values. Remember, it's x, y. The second number is our output. So I'd take the 1 as my first input value, the 2 as my second, the 3 as my third, the 4 as my fourth, and I have a last input value of 5. And that's all there is for my domain, where D stands for domain. So I have only 5 domain values for this set of ordered pairs, or this function. The range, again, the range is all possible output values. So again, I come and I look at all the y values, or the output. And again, just like before, I do a set notation, and I say, all right, the outputs are a 3, a 5, a 7, a 9, and an 11. And those are all possible output values. So the domain of this function here are the numbers 1, 2, 3, 4, and 5. The range are the numbers 3, 5, 7, 9, and 11. Now, there are many ways to represent functions. This is just listing them as a set of ordered pairs. We could also do a table where they're just say, okay, here's my x, here's my y, so here's my inputs, here's my outputs. 2's paired with 7, 8's paired with 6, 12's paired with 10, and 15's paired with 22. So if we wanted to find the domain, and normally when you write domains and ranges, you want to write them in ascending order, from least to greatest. You don't necessarily follow the table or the set of ordered pairs. These ones already happen to be in ascending order. So you notice over here, they go up 3, 5, 7, 9, 11. But when we go to do this one, you'll notice the range goes down and then back up. But when we do the range, we'll actually list the 6 first. But the domain, smallest domain value is a 2. Then there's an 8. Then there's a 12. Then there's a 15. So there are only 4 domain values. The values 2, 8, 12, and 15 is the domain of this function. The range are the values 6, 7, 10, and 22. So again, you usually start with the smallest one, which is 6. Then you do 7. Then you do the 10. And then you do the 22. And again, I want to emphasize that we always go from least to greatest. These are not paired like this. This is not how they're paired. The table shows how they're paired. When you're listing the domain and range, you're just saying, hey, my domain values are those. I'm not worried about the range when I'm looking at just the domain. Likewise, when I'm looking at the range, I don't worry about the domain. The ranges are just the numbers 6, 7, 10, and 22. Another way they represent functions is what's called a mapping. This is a mapping. And the first oval or bubble is usually, and they'll usually even label it as the input or your x values. And the second one, they'll usually label as your output, but they don't always label them. Just remember the first one usually has arrows pointing to the second one, and that's how it's mapped. So for instance, when I go to do the domain of this function here, my smallest domain value is -7. Then I have a -3. Then I have an 8. And then I have a 10. And you can't see that because I slid over too far. So my domain are these values that are in this bubble. My range are the values in the second bubble, which are the smallest ones, 2, then 3, and then 5. And I want you to notice that the domain and range here do not have to have the same number of values in it. They don't. You can have a lot more domain values than you can have range values. But you can't do the other way around. You can't have more range than there are domain. And we'll talk more about that when we talk about the exact features of a function or what creates a function. But so we've represented these functions as a set of ordered pairs, as a table, as what's called a mapping. But we could also represent them in a graph. So in a graph here, we have this graph here. X, the horizontal, will always be considered our input values. Even if it's not labeled X, we consider the horizontal the input. The vertical is always considered the output, normally Y, right? And so if I was to say what the domain of this one would be, what I do is I look for the points and I find their X values. So I look down to see what its X value is. The first point to the left, because we start at the left and work to the right to go from least to greatest. First one's a -3. Its X value is -3. The next one, as we move to the right, is this point here, which has an X value of -1. Then I have an X value of 1. And then I have an X value of 3. And last, I have an X value of 4. So I have 1, 2, 3, 4, 5 domain values, right? But now let's do the range. Now, if you'll notice something about the range, I really only have 3 range values. Even though I have 5 points, 3 of the points share the same Y value, the same output. So I do not need to list them 3 times. I just start down low and I work my way up till I get to the first point I come to. And it has an output or a Y value of 1. Then I continue up till I find the next output, and there happens to be 3 that line up. They all have an output of 2, and I don't need to list it 3 times. And then I move beyond that output of 2, and the next one I come to is a Y value or output of 5. And so my range is quite a bit smaller than my domain. My range is just the numbers 1, 2, and 5. My Y values. So far, I've only done functions that are what we call discrete, where there's just a bunch of set of ordered pairs where there's nothing in between. We can have a function that we consider to be continuous. In other words, every point in between 2 values is in the domain, and every point in between 2 values is in the range. So for this one, the domain, its smallest value would be a -4. So I would do -4, and then I'm going to say I'm going to have values that are greater than that. Now this is a less than symbol. What I'm saying is -4 is my smallest, the least amount I have, and then my X, because again, horizontal is X, my input, my X values will be greater than, that's why I'm saying greater than the -4, or less than, and how far to the right do I go on this? Well, I go up to +4. So there is my domain values for this function. And it's all values in between -4 and 4. When I go to my range, again, I'm going to start at the very farthest down. So as I'm coming up, the very lowest point I have is this point here, and its Y value is -2. So I have a -2, and then I have values going up. And so I'm going to talk about Y, because remember, Y are usually my outputs. So I said Y values, or my outputs, are going to be greater than -2, or -2 is the smallest my Y can be. And I can go all the way up to, I can go past 1. So even though it's like overlap horizontally with my Y values, I have multiple same Y values up till I get to here, and then I only have them on the left. But my Y values go all the way up to a Y value of 3. So I go to 3. And there's my range, the Y values from -2 to 3. If you have questions, please bring them to class, but this should allow you to accomplish today's assignment.